Hello, students. Welcome to our first lab of the year. Before we get into this, I want to talk about the science practices. So a big part of the AP curriculum are these science practices, things that you should be able to do to engage in real scientific work. So briefly, here they are. These are kind of part of the official curriculum for AP Biology. One, concept explanation, simply explaining concepts, processes, and models presented in written format. Two, visual representation, analyze visual representations of biological concepts and processes. Both of these we sort of get at during, kind of the more lecture-y part of the class where we explain how things work, and then we look at diagrams to kind of understand them. POGL exercises engage you in work in both of these science practices. The next really are more about the lab experience in the class. So questions and methods, determine scientific questions and methods. What should we investigate? What's something that's sort of studyable using the methods of science, that kind of thing. Representing and describing data. So we collect some data. How do we analyze that? What do we do? How do we graph it? How do we create a data table to best present that data? Number 5, statistical tests and data analysis. This one's going to be new. I'm guessing of all of these, this is the one least familiar to most of you, but we're going to actually learn in this lab how to do some simple statistical tests. And then use some mathematical calculations to analyze and interpret the data. And then finally, argumentation, develop and justify scientific arguments using evidence. In other words, making a conclusion. So once you've analyzed all the data, what does that data tell you? So those are the science practices in a nutshell, and these are going to be woven throughout pretty much everything we do in this entire class. So let's apply those to this lab that explores surface tension. So here are the objectives for the lab. One, you're going to investigate how molecular structure affects surface tension. That's kind of the content aspect of the lab. But then there's some process things. You're going to review how to write a lab report and what elements should be included in each section. So I'm guessing that in the past you have done some work writing lab reports, purpose, hypothesis, methods, results, conclusion. But we're going to review those and just kind of make sure we're all on the same page. 3, you're going to review how to use Google Docs and Google Sheets to type lab reports. Google Sheets is a spreadsheet program, and part of this is you're going to learn how to use that spreadsheet program to collect data and to graph that data, which is a very powerful tool. And then finally, you're going to apply statistics, specifically standard error, of the mean and standard deviation as well, to analyze experimental results. And I'm kind of assuming that's going to be new for most of you unless you've taken a statistics course. So the final objective, actually, sorry, one more, is that you're going to develop skills in effective collaboration. Now, what do I mean by collaboration, and do I have to do it? The answer is yes. Pretty much anywhere you look in the professional world, you will see people collaborating. Most of us grown-ups work in teams. I myself have a team. Dr. Houtz and I are a team. We work together to figure things out. The biology team, the chemistry team, the physics team. And what we have found as we've gotten better and better at working at teams is that we deliver a better product for you guys. And so working with other people is a vital skill and something that is going to be a huge part of this class. So let's talk about what that is. So there's these kind of different gears that work together to get you to effective collaboration. And so at the first most basic level is just simply cooperation. That's where you work loosely together. You're mostly independent, but kind of come together for mutual benefit. So an example, hey, I'll go get the supplies for a lab table. That's cooperation, and that's kind of a good thing, but it's not quite what we're shooting for. It's not the same level of collaboration. The next level is coordination. This is where you make plans to complete a common task together. An example of this that you should not do would be, hey, I'll write the results section and you, my partner, should write the conclusion section. Sure, you're sort of coordinating. I'll do this, you do that. Again, not quite collaboration yet. It's you're helping each other out, but not good. And this particular example I want to make clear is actually considered academic dishonesty. You should be fully engaged in writing each portion of your lab report, so don't do that. And then finally, collaboration. So true collaboration is where you work interdependently toward a common goal. You bounce ideas off each other. You hold one another accountable. So an example would be you're kind of reviewing each other's lab write-ups. And so you're reading your partner's lab write-ups and you say, hey, I really like what you wrote for this source of error. Maybe we could add this. And then you both kind of make adjustments to what you've written. And in working together, you've kind of created a better sources of experimental error section for your lab write-ups. Okay, so it's this higher level. It's not cooperation. It's not coordination. It's true collaboration. So you are going to be collaborating on a particular experiment today. And in this experiment, it's very simple, the setup. You're simply going to be dropping different liquids onto a penny to see how many drops you can add before it overflows. And the three molecules you're going to be adding are water, and there's its molecular structure. Isopropyl alcohol, there's its molecular structure. And then basically dish soap in water, and there's its molecular structure. So you got these three liquids. You're going to drop each type of liquid onto a different penny and see how many drops can add before it overflows. Now, anytime we do a lab, for the most part, there's going to be two sections, and those two sections are the pre-lab and the post-lab. The pre-lab must be completed before the experiment, and it includes the title, the purpose, the hypothesis, the methods, and then blank data tables for your results section so that you're ready to record that data. This is typically going to be due the day that we begin the actual investigation. The post-lab is going to be due after the lab, and we're going to basically carry out our experiment. We're going to collect data. We're going to analyze that data, and then you're going to write up the post-lab. This includes the completed results section, so filled in data tables, probably graphs, and then the conclusion section. Okay. Now, information on how to write a lab report can be found on Schoology, and I want to just show you exactly where. You could click this link, obviously, but if you go to the administrative nuts and bolts folder on Schoology, you will find lab resources, and boom, how to write a lab report. Note also there's a tutorial we're going to do during this lab. That tutorial is available to you all year long in this folder. And then the lab report rubric for how we grade the labs is also available to you. Note that we've given you the rubric and how to write a lab report in paper form at the very beginning of the year, so you should have those documents already. We also gave you that formula and equation sheet at the start of the year. So you should have most of this stuff in your folder already, but we thought we should link it somewhere where it's easily accessible throughout the year. So, so your task for today is to complete your pre-lab. And in order to do that, each individual should complete your own and submit it through Schoology, and then aim for true collaboration. Again, having one student write one section and another student write another, and then exchanging, that's not collaboration, and it is considered academic dishonesty. You must be fully engaged in writing each part of your own lab report. And by the way, when we grade these, we sort of grade them in groups. So I'll read all four group members, and then I'll go to another group and read all four of theirs, and then go to the next group, read all four of theirs. So if you're just simply copying exactly word for word one another, it's obvious, and we know, and we will have to have a conversation about that. So don't do that. That's not true collaboration. Okay, so your task for today is to go through the following slides with your team. And what these slides will have you do is they're going to have you go through the the pre-lab exercise. So this slide talks about independent versus dependent variables, as well as controlled variables, which hopefully you're a little bit familiar with, but make sure we tighten that up because that's pretty central to much of this course. You're then going to figure out how to write a title. You're going to learn how to write a purpose. You're going to learn how to write a hypothesis. For methods, since the procedure is pretty much just given to you, like here, do this, all you need to write is see lab handout, but you still want to have a discussion about your methods. You're going to have one person is going to be adding drops to this penny. And so you might want to discuss, how do we make sure that we're adding, that we're consistent? If we do 10 trials of this, how do we make sure we're really consistent? Should the penny be cleaned in between different trials? Where should I add the drop? Should I add it to the edge? Should I add it to the center? Does it matter? How quickly should I add the drop? Should it be do, or should it be do, dude, have some conversations about how do we make sure we have good data, and then even, what about limiting bias? If the student who's dropping kind of expects a certain result, what do we do? Bias? I don't know. Should we worry about that? Do we want to keep it a secret which liquid they're using at any given moment? I don't know. We should talk about that. Okay. And then finally, results. For this, you're going to need to create a blank data table similar to this one below using Google Sheets. There's this tutorial that will tell you how to use Google Sheets because we're kind of assuming you haven't done that before. And so make sure that you use that and follow those directions very carefully because much of what follows in terms of data analysis relies on you having a well-constructed table in Google Sheets. Okay. And so then all throughout this, you should be using that lab report, writing a lab report document to make sure you're doing everything well and accurately. And at the end, maybe use that lab report rubric to just kind of recap and self-assess and make sure you're doing a good job. Remember, be thorough but not concise. You don't need to spend 45 pages writing out every single little data point. You want to be thorough, but don't ramble. Okay, kind of get to the heart of the idea and write it clearly and concisely, and move on. Okay, so once you're done with that, you are done with the pre-lab, and that will be your homework, is to get that pre-lab finished by the day of the lab, and then we'll pick up with the post-lab later. Good luck.